This project was a roller coaster, yet it was a very rewarding experience. I first attempted this project back in 2021 when I was first starting with Arduino. I didn't have a 3D printer then, so I took a compartment box, stuck a bunch of components in it, and that's my hair blocking the shot, cause back then I looked like this and this. Here are some more shots of the project, which, for obvious reasons, did not work. Fast forward to today, I was wondering which project idea I should work on next. And that's when it came to me. That was it, I was going to build a DJ controller. If you know me, you know I jump right into my project. I fired up EasyEDA, drew a quick schematic. I used a bunch of pots, encoders, switches and push buttons, and I connected them all to 4 CD4067 16-channel multiplexers, one CD4051BE 8-channel multiplexer, an MCP23017 I expansion board, and an Arduino Pro Micro. Then I quickly created a PCB and I used only user-submitted footprints for all the components. Finally, this project would definitely not be possible if it weren't for today's sponsor, JLC PCB. JLC PCB is one of the largest PCB manufacturers in the world. They provide the highest quality PCBs for the lowest prices. They also do flexible PCBs, PCB assembly, SMT stencils, 3D printing services, CNC machining, and mechatronic parts. You simply need to upload your Gerber files, select the color of the PCBs and all your desired settings, and you can have 5 boards up to 10 by 10 centimeters for only $2. Thanks to JLC PCB for sponsoring this video. Now back to the project. The PCBs came in just a week. The packaging and the PCBs themselves were wonderful. Just bask in the glory of these wonderful boards. They are as big as my 16-inch MacBook Pro, and I couldn't be happier. I was very excited to go ahead with my project, even though I didn't have all the components I needed ready. What I did have was an Arduino Pro Micro, 4 old 16-channel multiplexers, salvaged from old projects, but I wasn't sure if they would still work. A bunch of 8-channel multiplexers, and an I/O expansion board. I had to desolder the pads of the multiplexers so I can solder new pins. I thought desoldering was easy. It was not. I spent a good part of an hour desoldering just 4 multiplexers. After finishing, it was time for a quick desk clean. Next, I proceeded to visually inspect the PCB, and it was time to solder pin headers to all the components. First up was the Arduino Pro Micro. At this point, I was very excited that my project was making great progress. I even organized my multiplexers, placing them next to each other. You can really tell I'm excited. I am rarely disorganized. Now was the time to place them on the PCB and solder them. So I carefully inserted each component in the correct position and orientation, and I soldered them to the PCB, without testing if they are working beforehand, of course. And finally it was time to solder the Arduino. Along with the components I just soldered, I had exactly the right amount of push buttons left, so I went ahead and soldered them as well. I was expecting a delivery of new multiplexers, push buttons and other components, but they weren't due anytime soon. After soldering the push buttons, I got the encoders, which were the most important part of this project, so I quickly soldered them as well. And after running my test Arduino sketch to test my connections, I was surprised to find out that my controller didn't work. This was my second actual PCB made, so the chances of making a mistake were high. After a week of inspecting the PCB, the schematic and my soldering job, I couldn't find any problems, so I decided that the old multiplexers I used must be damaged. I tried to desolder one of them, and when that didn't work, I soldered pin headers on top of it to connect it to a different Arduino. And when that didn't work, I took the pliers and ripped it out of the board. Luckily, I managed to find a local seller who had just one multiplexer in stock, so I got it. I decided to do the smart thing. I soldered pin headers to a new PCB, board number 2, so I could test if it was working with a new Arduino and a new multiplexer. I also tried to desolder one of the push buttons, but by now you know how that might have gone. So I took the board, plugged it in, uploaded the sketch, and it was working. I was right. The old multiplexers were damaged, and all I had to do was use new multiplexers. A couple of weeks passed and I finally got all the components I needed in the mail. New multiplexers, new push buttons, new encoders and the potentiometers. First I unpacked my multiplexers and I had to solder pins to them. Before I made any rash decisions, I decided to do the smart thing again. I soldered female pin headers for all the components on the second PCB, just to test it. Luck ain't got nothing on me. I'm not winging it this time, I thought. Here's the tricky part, and the part I didn't know when I was starting out, and the main reason why my project didn't work back then. In order to reliably catch the encoder signals, they have to be wired to hardware interrupt pins on the Arduino. The Arduino Pro Micro has only 3 usable hardware interrupt pins, pins 2, 3 and 7, which means that technically we can only use one encoder. However, we can expand on those pins by using an I/O expansion board, like the MCP23017, which we can connect to pins 2 and 3 of the Arduino, which are also the SPI pins, and we can connect the interrupt pin from the I/O expansion board to pin 7 of the Arduino. This will allow us to have up to 8 encoders connected to a single board. This piece of hardware is what allows this project to be feasible. I even used a brand new Arduino Pro Micro. After placing all of the components on the board, uploaded the sketch again and it still wasn't working. After hours of debugging, I found the culprit. The old 16-channel multiplexers weren't damaged. Well, probably. It was the 8-channel multiplexer's footprint that was wrong. The person who made it created it backwards, so when I placed the footprint, I placed it on the back side. If you look at the signal pins A, B and C, they are flipped according to the pinout schematic. No biggie, I would just solder it to the front of the board. With my newfound confidence, I brought board number 2 to my workbench, pulled out the components and I started getting ready to finally have my project finished on a new PCB, board number 3. I already had the push buttons in place, so I soldered those first. Next, I placed all the multiplexers. And finally, the MCP23017. Next order of business, I placed and soldered each encoder. After that, I soldered each potentiometer. The board was starting to take its final form. Finally, I placed the 8-channel multiplexer on the front side of the PCB. For the sliding potentiometers, I only had these ones that were mounted on a breakout board. So, you guessed it, I had to desolder them first. After a while, I managed to get one out, and I quickly figured out the best way to do it. Now looking at the sliding potentiometer, the pins on mine were different from the footprint and holes on the PCB. So I just bent the signal pin and I placed it in one of the mounting holes, which were free to use, and ran a small jumper wire. I proceeded to do the same with the rest of them. Finally, it was time to solder the Arduino Pro Micro. Needless to say, my project still wasn't working. Had I spent more time debugging the problem with the 8-channel multiplexer, I would have noticed that the whole footprint is wrong. My Balkan roots are really pushing me into blaming the person who submitted it to EasyEDA, but ultimately it was my fault for not checking. As you can see, it's not just the signal pins that were on the opposite side. If you look at the 3 ground pins, according to the pinout, the signal pins should be on the opposite side, which they are not. If the VCC pin is supposed to be on the same side as the signal pins, it is not. It's on the opposite side of the ground pins. It makes no sense. Never mind. I knew what I needed to do. I had to desolder the multiplexer, attach wires to the PCB and solder them to an IC socket, and then just insert the multiplexer. I cleaned up the PCB and went back to desoldering. I was starting to get used to this pattern. First I would solder something, then decide I need to get it out. I would try to desolder it, and when that wouldn't work, I'd just get the pliers. And I have to say, the pliers do work. It was time to test my contraption. I just needed to place a new 8-channel multiplexer. I tested my board and finally it was working. I didn't record my reaction of relief at the time, but if I did, this is what it would look like. I was ready to clean up my mess. While I'm cleaning up my workbench, let me tell you about the next chapter. So, turns out not everything was working correctly. When I used the pliers to rip the multiplexer out of the PCB, I somehow shorted it, so a few of the multiplexer pins were touching, causing one potentiometer not to be read at all and another pin to register 2 potentiometers. This meant I had to start over with a new PCB. Sadly, I didn't film any of it, but board number 4 was working flawlessly. It was time to design an enclosure. Since the PCB is as big as my 16-inch MacBook Pro, I had to split my design. I split it in 3 parts, glued them together, and I proceeded to add heatset inserts in my screw holes. And when I went to screw the board, the components didn't really fit the holes. So I created a new design. I enlarged the holes, then I split the enclosure again, but in 2 parts, and the rest is history. I added some heatset inserts, then screwed the PCB to the enclosure. This allowed the case to stay intact without gluing it. Finally, I placed the mechanical switches in their mounting holes in the enclosure, which also acts as a plate, and it provides better stability overall for the PCB. At this point I figured out I kind of missed the USB hole by about 2 mm, so I used my Dremel to enlarge it. The final part was to beautify the DJ controller by adding all the necessary caps. Wait until you see the Jog Wheels. Let's look at the code for a moment. The main reason this project is working like a DJ controller is because it has so many encoders. The only way that is possible is by using an I/O expansion board. I found this code online by Curiosity Workshop that utilizes the MCP23017 expansion board, which really helped me figure out how to use it. I edited it a bit so I can use all 8 encoders with just one interrupt pin. The rest of the code just initializes the multiplexers, and we basically assign each button or potentiometer to a specific multiplexer. Then we read them and dynamically send a CC message command via MIDI USB. Then we can simply map those MIDI signals in our DJ software, in my case Traktor, and that's it. It's that simple. So with this project being done, I decided to invest in this cool little desoldering station, so I can get all my components back, safely. It's got a bit of a learning curve, but it's already working much better than what I was trying to do before. I guess if there's a lesson to learn from this video is to never give up. You will face many troubles and roadblocks, but the answer may be just at the next step.